Hi everybody, we're gonna solve or explain questions. This is kind of a not so difficult topic, but we need to understand it. So in this video, I will explain some notation, and then when you get to your homework, you just practice these sets. So this is about set notation. The first one we talk about is the union and the intersection of two sets. So the union of sets A and B is written with this symbol of U and pronounced, of course, A union B is defined as follows. Is the set of all elements that belong to either A or B. So we're talking about both of them. And so in the example here, A is 1, 2, 3, 4 has these elements, and B has 1, 3, 5, 7, 11. So the union has both elements. So 1, 2, 3, 4 from A, and of course 3 repeats, but we won't write 3 twice or 5 twice. Then we have already 1 and 3 and 5. So we're missing 7 and 5, 7 and 11 from B. So this is the union. You write all the elements that are in both of them. Of course, you're not going to repeat the same number. The next one is A intersection B is the set of all elements that belong to both A and B. This is a common, just like a common factor. These are the common elements. So as we look here, 3 is there, 1 is there in both of them. So and we saw, if you've done like previous math courses, let's say intermediate algebra, you saw these in inequalities. Now for the subset, we say the set B is a subset of the set A, written with this symbol, is pronounced B as a subset of A, provided that every element of B is an element of A. So for example, 1, 3 is a subset of a set 1, 2, 3, right? So in this case, this is a set B and this is the set A. And you need to find out how many subsets you can have when you from a set. And this is used in, for example, the knowledge theory, when there is a different sets of knowledge that are needed to be figured out. And when they create the map, they need to know how many subsets and their connections. So hopefully later on, we get to talk about that. So what is a disjoint sets? Disjoint sets, A and B are disjoint if they have no elements in common, right? Which means their intersection is 0. You're not going to find anything in common. So one set has 1, 2, 3, and one set has 4 and 5, for example. Those are disjoint sets. So if you want to list the subsets, what I'm talking about, so for example, you need to know A, B, and C. What are all these subsets? Well, the first one is the empty set, this first one here. Then there is a subset that has element A, subset element B, subset element C, right? Or a combination of 2 of them, or 3 of them. So if you see this, these are 3, and this number of subsets is kind of 2 power 3, which is 8. And you'll see that you have 8 subsets here. All right, so when you go from this empty set, 2, 3, 4, 5, 6, 7, 8. All right, There is something also we talk about as a complement. If you did geometry, then you know what the complement is. So for example, 90 degrees angle, the complement of 30 is a 60 degrees. So it's the other part. And same thing here. So if we have a set that has these elements from 1 to 9, and we have a subset 2, 4, 6, 8, the complement, so let's look at 2, 4, 6, 8, then the complement is going to be 1, 3, 5, 7, 9, right? And it's denoted by this. So as a summary for 5.1, and homework problems are going to be kind of straightforward this way. And just if you have multiple of them, you just follow in order, right? So the union, it's such that this symbol here belongs to A, or X belongs to B, right? So this does not belong to, but this belongs to. For the intersection, you see it's not or, that's the difference. This one is or, this one is and, which means the intersection or the overlap. And the complement, and you see now that symbol, and the subset if X belongs to A, whenever X belongs to B. And that concludes 5.1. And in this video, since this is kind of connected, and 5.2 is also kind of same idea, we'll talk about it here. Fundamental principle of counting is one that requires us to determine the number of elements in a set S. Counting problems arise in many applications, of course, in math. It's actually a big topic in math, and we'll see some more details later on. And so let's start with Fs is any set. We will denote the number of elements S by Ns. So if you see Ns, means the number of elements in S. For example, this set S has 1, 7, 11, which means 3. Right? 3 elements, 1, 2, 3. So NS equal 3. And this other set S, as example, has 9, right? And if you see this symbol here is the empty set, which has no elements. And we need to find, let S and T be sets. I need to find this inclusion-exclusion principle, which means the number of elements in the union of sets S and T, it equals to the number of elements in S plus the number of elements in T minus the number of the elements in the intersection. All right. So you can easily do an example on this and see one set has 1, 7, 11, one set has 1, 7, 10, 12, 13, and you count and you see the intersection, how many, and you subtract. So this can be easily done and see how many, the number of elements there. All right. So notice that this connects the union, of course, with the intersection and the number of elements in each one. And there is a special case where, of course, we saw that disjoint where there are no common elements and the intersection is 0. In that case, we say both of them. So the number of elements in the union is going to be the sum of the number of elements of each set. Okay, thank you. And try these problems, and we'll talk about other sections.